Okay. There we go. Everyone can hear me?
すみません。それでは、Practical Ruby Project with MongoDB Alex Sharp さんお願いします。
Everyone can hear me okay? Good, cool. So I'm Alex Sharp. Welcome to Practical Ruby Projects with MongoDB. First, I just want to say this has been an amazing conference, and the presenters, or I'm sorry, the organizers have just seemed really dedicated and extremely organized. And I just wanted to say that I've been really impressed and have had an awesome time. So thank you to all you organizers. This mic is really cool. It makes me feel like a Backstreet Boy. So, which I always wanted to be. No. So, who am I? I'm Alex Sharp. I work with a company called OptimisDev. We build a web-based electronic medical records solution. A lot of people have asked me if I work for 10gen, which is the company that makes MongoDB, and the answer is no. I'm just a pusher, a peddler of their product. So, we're going to be talking about three things mainly today. I'm going to do a little rant on why it says here making the case for Mongo, but it's really making the case against relational databases, and then how Mongo can help. And then I'll go over some of the key features of Mongo and show some practical projects. So, as I said, this is really about the problems of SQL and relational databases. And SQL itself and relational databases are fine, except at least SQL was invented about 4 decades ago. And it was invented specifically to query information out of relational databases. More specifically, it was created to query data. To me, this is a big problem because as software developers, we don't really work with data. We work with objects, or maybe you want to think of them as structured data, but as object-oriented programmers, we work with objects. And because of this, we're not really concerned about storing data. Not data and data alone anyway. We're more concerned with persisting state of our objects. And as I said, data is not equal to objects. Therefore, bold statement, relational databases are an antiquated tool for our needs. Boom. Flame wars begin. So what, right? I was actually having a conversation with someone last night about this. And the so what is sort of like, I'm efficient with relational databases, right? Like I know how to do my thing. I know when to use a many-to-many, and there are lots of awesome tools around that. But as we all know, there's a major impedance mismatch here between relational databases and modern software languages. And that is that relational schemas are really designed to store and query data, not persist objects. And so to deal with this, we have these really sophisticated pieces of software called ORMs, object relational mappers. They exist purely so we can create this mapping from our object state to the state in which that we need to store our objects, or rather, our data in this case. And this really sucks for a number of reasons. I think there's a lot lost in translation when you almost automatically do this thing in your head where it's like, okay, if I have some native property and you know it's going to need to be stored in a many-to-many join table, I think you're losing something there. Because that's the process, right? That's what's efficient. But I'm not content with that. And so yeah, we're sort of forced into this relationship where we have to create relationships for data even when we don't need them. And all we really want is properties for objects. And as I said, this is not efficient. Even though we are efficient with these practices in the long term, I don't think this is efficient. And many years, MySQL came out in the mid-90s. SQL's been around since the 1970s. I think we can do better. So with that, I have kind of a weird example. I should preface it, or else none of you are going to want to have beer with me tonight. So the first time I gave this talk, I used an example here of friends and friendships. And somebody, you may know the name pragmatic, pointed out, well, that doesn't really fit here because it's sort of a two-way relationship. So I was like, yeah, you're right, Pat. So I needed an example that is inherently a one-way relationship. So don't judge me here. I came up with this example of stalkings, as in I am stalking somebody. I promise I'm not an actual stalker, but if I were any good at it, you wouldn't really know, would you? So if we wanted our person object to be stalking some of his friends, right? Assumedly, those friends wouldn't know about it. This is, in other words, this stalking's property is a private property to the person object, or the person class. This is what the native Ruby object representation would look like. And then this is what a JSON representation would look like. And we'll see later that Mongo actually stores things in binary JSON, which is very helpful. And I think we can all agree that JSON is a pretty damn good serialization format. And then here's what this would look like if you had to represent this in a relational database. So all of a sudden, we have this thing, we have this stalkings table. And again, this really sucks. On one hand, at the object layer, we have this very private property, right, stalkings. As the owner of those properties, I'm the only one that should know about them. However, at the database layer, I have to give them a first-class, very public representation. I have to give it its own table. And this doesn't really make sense to me. It's, again, it's the impedance mismatch, and you know, it's not the end of the world, but 30, 40 years down the line from when SQL was invented, I think we can do better. So here's sort of the degradation of the object model from starting at the Ruby object layer down to the storage layer in a relational database. And again, I think we're working too hard here. So I keep coming back to this because I come back to it myself when I'm working with Mongo. Again, because I'm pretty efficient with my SQL. It's like, it's not that bad. I know how to get stuff done. Maybe. But we're software developers, and we're Ruby developers, even better. We should be pushing things forward. We should be proactive and not be satisfied with the status quo if we don't agree with it, and I certainly don't. So all this talk about we can do better, what is the ideal persistence layer? In my mind, it's the ability to persist objects in their native state. It shouldn't interfere with application development. By that I mean, you shouldn't have to be making these decisions when you're designing your object model based on how you know you'll have to store them at the data layer. And at the same time, we need features to build web apps. We can't just store everything in a key value store, because that would get very, very inefficient very quickly if, say, we couldn't index on a name field or whatever. So Mongo to the rescue. What is MongoDB? It is a schemaless, document-oriented, scalable database. Let's talk about its strengths. It's schemaless. What this means in practice is Mongo doesn't care about, it has this concept of collections, which are like tables in relational databases. But it really doesn't care about what you put in those collections. It's kind of like Ruby in the sense that if you wanted to be really, really irresponsible and maintain zero schema whatsoever, it will let you do that. Nearly all of your operations are going to be painfully slow. Largely because reads scale in Mongo similar to a relational database in that you are indexing on specific properties. But again, if you're using this responsibly, schemaless is really, really awesome, especially for rapid iterative development. I don't know about you, but there's been so many times when I'm working on an app and it's like, okay, I want to add a property to this object. I need to go run a migration now, and it's like, it's just silly. You shouldn't have to do that. It's not, again, it's not that hard, but it's why? And as I'll show in some examples later, a schemaless database in general makes possible some things that are either like ridiculously hard or, and therefore you're just like, I can't do that. Or they're literally impossible in a schema database. So, document-oriented, what does this mean? It means that Mongo doesn't have the concept of a row. It understands documents. And as I said, it stores things in binary JSON. So it's literally just storing JSON documents. A concept people get really confused with is the idea of embedded documents. All this is a property on an object in Mongo that is another JSON object. Again, documents, JSON objects, not rows. One reason this is really awesome is because Mongo has a very rich and I think familiar feeling query syntax if you're comfortable with JSON. And again, as I'll show in a later example, embedded documents allow you to do some really cool stuff. And this is probably one of the biggest hurdles to get over when you're starting to use Mongo, is getting used to the idea that things are going to be modeled differently. Maybe it takes a while to like break off the relational chains and how you think about you're going to persist your object model. But embedded documents allow you to do some really, really cool stuff. So I'm going to show a few examples, and they're all going to be based off this document. So this is something I pulled out of a project that I have called Bunyan. So we use Bunyan at Optimus to store a little bit of additional data about every request. We largely use this for troubleshooting, but we store like the status, the request method, the control and action combo that was requested, and then we store some stuff about the user. This is really the kicker and why we do this. Because usually we'll get an error report that's something along the lines of, you know, John at wherever, at clinic B, experienced some really bizarre error. He got a we're sorry page, right? And I can't really do anything with that. I can go like try to crawl through Hoptoad or whatever. What usually ends up happening is you get the session ID from Hoptoad, and then you go like shell into the production box, which is just bad, trying to figure out who this user was. And even at that point, you don't have a click path. So that's what we use this document or this document structure for. So to illustrate the query syntax, logs is like a collection instance, by the way. So this is just doing something similar to select all from logs where the status is 500. Pretty simple stuff. And then this should be like doing an and, except you can't really do this in Mongo, or I'm sorry, in SQL, because you would have to do a join here. But this is saying, find all documents where the status is 500 and the user has a last name of equal to Doe. So again, user is an embedded document here. And this wouldn't really, well, it would be possible in SQL. We would just have to join across to probably some users table. And in this use case, that would be really painful, having to maintain more than one table, because we're really concerned with requests here, request data. There's really no need to have a separate users table, and it would make things much harder to maintain. So this is one of those examples where embedded documents is really, really awesome. You can also do regular expressions natively in the Mongo shell and also in the Ruby driver. So this would enable you to do something like, show me, this would return any request methods that start with P, so posts or puts. And it's case insensitive, so regardless of how they're stored. So just a little flavor of the query syntax. There's a whole lot more stuff you can do. So big data. Mongo is really good at handling big data. Primarily because they added this feature called auto sharding. And the gist of it is, so for those of you that don't know, sharding is when you have to, when your database grows to a size where you have to actually split the database. A lot of times you'll do it along like very logical canonical lines. Say if you have a customers table, you have customers in the US and you have customers in Europe. Maybe you'll shard on the country of the customer. And this is really painful in relational databases, largely because of joins, because you cannot join to a separate node. Mongo handles this pretty gracefully with this feature called auto sharding. You basically say, here's the key that I want to shard on, or the property, and here's a cluster of nodes, just go do it. And it just works. It's pretty awesome. Another major feature of Mongo is very fast writes. So Mongo was born out of, the two guys that started it came out of DoubleClick, wherein every request means they're doing at least 2 or 3 writes, add impressions, that kind of stuff. So fast writes were a big priority for them early on. And Mongo has this concept of an upsert. So upserts are really cool. Basically, an upsert is like, if this thing exists, update it in place, the entire document. And if it doesn't, create a new document. We all know, like, the typical Rails controller action example is you go find the record that's been passed in from the ID parameter, and then you call update on it. So you have 2 operations there. In Mongo, you can just pass the ID in. Actually, I have an example. And it'll do just 1 operation. And there it is. So save in the Mongo Ruby driver. By the way, all these examples are just plain vanilla Mongo Ruby driver. I have a slide, a couple slides at the end about some of the popular ODMs, object document mappers. But especially if you're getting started, I highly, highly recommend just toying with the Mongo Ruby driver because it keeps you much closer to Mongo proper. So save in the Ruby driver does an upsert for you. There is an insert command. I recommend you use save so you can take advantage of upsert. And so we inserted initially, and then once we have it, that first example will actually return the ID, and then the second example will update it in place. And again, you have to, it's a hard update. So for example, if I would have just done ID, post ID, and title, and not body, that document would not have a body property anymore. Anyway, so aggregation. This was a kind of later feature. I think the stable version is now 1.6. I think this was added in like 1.2 or 1.3. So Mongo does like Google GFS style aggregation with MapReduce. And you write your MapReduce functions in JavaScript. And this is what a very simple MapReduce function does. I have a demo a little later that uses this MapReduce function. All we're doing here is really emitting every controller action and giving it a property count of 1. And then in the reduce function, for each key, we're going to get a collection of these count objects. And we're just going to sum them so we can get the total number of hits or count for each controller action. Mongo does reads very quickly too. And like I said before, just like a relational database, you achieve fast reads with indexes. So this is how you create indexes with the Ruby driver. This command is a little misleading, I think, especially if you're used to active record syntax, because create index is a sort of one-way only command in active record. But Mongo has, the native command is called ensure index. So this actually calls ensure index, which means if you call this twice, it's not going to blow up on you. It's just going to say, OK, that index already exists. I'm not going to go create it again. And it has very familiar concepts in relational database world. So the first example, we're just doing a simple index on the status property. The second example, remember user is a embedded document. So we're creating an index on user's first name property. And then we can do compound indexes as well, just like in a relational database. So cool stuff. Some weaknesses. Well, I don't know, weaknesses. They're just non-features, rather. Mongo does not do joins at all. A lot of the, I know Mongo Mapper does this. I'm not sure about Mongoid. But, like an active record, if you can like eager load your associations, right? And active record will do the joins for you. In Mongo Mapper and Mongoid, it's just going to go to the database and do another query, which is fine. And a question that often comes up is, can you do references in Mongo? Yes, you can. You just store the other document's ID, just like in a relational database. Only difference is you're not going to get a join. Multi-document transactions, not a feature. If there's any one overriding philosophy of Mongo, it's speed. And so things like multi-document atomicity, they just don't care about it. And what's really cool is, because your schema is designed differently, a lot of times this doesn't matter. A lot of times you don't need, where you would need multi-document atomicity in a relational database, you don't need it in Mongo, which is obviously a big win. And there's no concept of like foreign key constraints or relational integrity, which if you're like me, that's a software level thing, not a database level thing. So that's the brief overview of Mongo. There's a lot more stuff. MongoDB.org is the official Mongo site. A lot of great documentation on there. I didn't cover replication because I don't think it's that exciting for like an intro. I think it's a little too deep, but there's a lot of great stuff and new features on replication. They just added this feature called replica sets, and I mentioned auto sharding a little bit. So definitely check out mongodb.org to learn about some other features. So there's 3 applications that we're going to like show how you, accounting, we're going to show how you would have done it in a relational database, and then how you end up doing it in Mongo. And then we'll go over a specialized feature called capped collections and how we use it at Optimus, and then just the traditional blogging example. So this is just a very, very simple general ledger accounting application. By that I mean all we're doing is recording ledger transactions. So if you're not familiar with accounting lingo, a ledger transaction has a credit and a debit, and that's it. You can have more for like complex transactions, but you're not going to have an endlessly growing number of credits and debits for one ledger transaction. And they're going to look, they usually look something like this. So in one transaction or a ledger entry, we might credit cash, which means we're going to withdraw. It's a little weird. Crediting an asset side of the ledger means you're going to withdraw from that account. So we're going to withdraw $100 from cash, and then maybe for some reason maybe we're paying off a credit card, right, with $100 or something like that. So as I said, each line item has like one parent ledger. And a line item can have 2 or more ledger entries. If it's more, it's maybe going to be 3 or 4. There are some kind of complicated transactions that you can have, but usually it's just a simple credit and a debit. And the most important part is the credits and debits must balance. And so this whole situation has to be transactional. And here's how you would model it in SQL, where you have entries and then line items. And of course, to make sure everything goes down smoothly, you need a database transaction because we're going to insert 3 records here. So in SQL modeling, we have to have multi-row atomicity to ensure that our ledger entries are up to date. But in Mongo, this isn't the case because this is actually a perfect example for embedded documents. Let me go back 2 slides. So this modeling is what I call sometimes like the pointless join, meaning that these entries are never going to belong to anything else other than this line item. And it's not quite the same as just a simple one-to-many association. The way I've heard some people describe it is like this is a contains relationship, where a line item contains ledger entries. This is different to something like an author has many blog posts, because an author doesn't contain blog posts, he has many of them. And I guess the technical significance there is that an author's blog post could grow infinitely forever, whereas this is, you're only going to have a few of these things, and they would never exist on their own outside, in the real world, I'm saying, outside of a line item. So the question is, like, why do we have to represent them as first-class objects in the database? We shouldn't, and Mongo makes it so we don't have to with embedded documents. So in this example, all we're doing is adding a line item to a ledger, and the entries, again, are embedded documents. And this is really great, and even more importantly, we don't need transactions anymore. And that's awesome. So to kind of recap here, we started out with this kind of complicated object model where you need multi-document transactions to be able to do this responsibly. And there was a fairly large impedance mismatch between the object model at the application level and at the database level. And with Mongo, the data model is simpler. We don't need transactions anymore. And I think that's a big win. So logging with capped collections. So by the way, if anyone has any questions, I'm kind of covering like some software stuff, like accounting and whatnot. So if anyone has any questions, just stop me. So capped collections are a special feature of Mongo. For any given collection, you can specify it as capped, which means it has a fixed size. And once it hits that size, it's very similar to memcache, where it's just going to roll off the last entry, except with Mongo, it's a first-class collection, so it gets persisted to disk. So the reason that we wrote Bunyan is because sort of the story that I explained earlier is that when things go wrong, yeah, you have a log, you have a Rails log, you have an Apache log, but you can't really do anything with those things. Even if you start adding additional stuff to it, you have to be like a serious master of grep or ACK to get any use out of that stuff. And that's just like craziness. So we created this library called Bunyan, so that uses cap collections so you can insert these things on every request. And this isn't a problem because writes, again, happen really, really quickly, and especially so with capped collections because the insertion order is fixed. The operations you can do are very, very limited. So everything happens really, really fast. And the fact that Mongo is schemaless makes this all possible. I mean, you could just marshal everything into a big text column in MySQL, but that kind of sucks. And you don't get any sort of queryability with that. That part of it's lost. At that point, you might as well put it in a text file, right? So the ability to just add arbitrary things to this log is really, really helpful. And as I showed earlier, to be able to add user information in an embedded document is huge. So basically, we capture these things on every request. We're able to query and analyze them, and the profit thing is, I don't know, it just sounded right here. We don't make any money off this. But it is a very, very helpful troubleshooting tool. And I have a demo of it, a very brief demo in a few minutes. So as I explained earlier, we get these like bizarre error reports, and they just, like, we can't do anything with them unless we go do irresponsible things like shell into the production box. So it'd be great to be able to see click path. So Bunyan is basically a wrapper around a MongoDB capped collection. It has a nice little configuration syntax, and it prevents you from needing to pass around a global or a constant in your app. The big missing piece in this is it needs a middleware API. If you are interested in contributing, that would be really awesome. I've been sort of marinating on this for a while and haven't been able to come up with something. I added an example to the repo yesterday, so there's something that can be used, but it's sort of use at your own risk. So this is what the configuration syntax looks like. You just give it what database you're going to use in the collection and then a size. And in Rails, you could do something like 1.gigabyte there. And the second part to this that makes this useful is this front end I created called PaperMill, which is just a little Sinatra front end. So I think this will work. Oh yeah, sweet. So this is PaperMill. So I'm searching for my name there. And so those things in the drop downs are all properties or keys in the documents that are stored. That's a little blurrier than I hoped it would be. So this graph at the top right here is generated by the MapReduce query that I showed earlier, which just adds up all the controller action properties and basically says like which ones have been requested the most. And so this is really helpful because it's usually like this user had an error, so I can just type the user's name in and see what he's done. This is all reverse chronological order. And I could say like, show me 500s. And I can see the errors, and then I can make some use of Hoptoad and actually try to debug this thing. So that's PaperMill and Bunyan and capped collections. So the blogging application, the example du jour. I'm not going to waste time showing what a blog looks like in SQL because I think we all know at this point. But to me, the important thing here is like this blog. A blog is like this really, really simple thing. A post has an author, a post has tags, and a post has comments. Pretty simple stuff. But like it's mind-blowing to me how difficult this still seems to be. It's sort of like ORMs. Like people have developed these really good pieces of software to do things like tagging and commenting. At least for me, like I don't even mess with it anymore. I just push it off to a service. But it's like, this should be simple, right? Like, it's a really simple object model, and it's just like, for some reason, it's just not. So again, embedded documents to the rescue. Tags can be modeled as just a simple, you can do embedded documents or just an array of strings, which I think is sufficient. And so, me personally, my blog is built in MongoMapper. And if you don't know, MongoMapper is John Nunemaker. It's actively developed. John's a great guy. Similar syntax to DataMapper, in that you're not inheriting from active record base, you're including things. Very, very easy to drop into Rails, and it's also, MongoMapper is great if you're coming from relational database world, because that's what John built it for. But again, if you actually want to like learn Mongo, you should look at the Ruby driver. But this is the blog, basically. This is, controller actions and views excluded. This is the object model for the blog, and that's it. And tags here is just an array of strings. That's it. Because, Mongo does big data well, so we really don't need to be concerned about having this like tagables join table, and just so we like don't duplicate data, and so we can like search on it. We can do those things anyway, and we don't need another table for them. Of course, we want our blog to be fast, so we should create some indexes. This collection method is given to you by MongoMapper. It's basically, collection is a native Mongo Ruby driver thing, and you can access it at any point in your MongoMapper models if you need to do like native Ruby driver stuff, various like Mongo-specific update commands. So again, I think this is a big win, because the object model is super, super simple, and that's what we want. Funny, I actually didn't want to use this example because it's extremely conceptual and kind of boring, but we're on that slide, so we'll do it. So reporting, and this is kind of cool because I was talking to someone last night at the party about reporting. Reporting in general is a pain. It's a hard problem to solve. You have to do all this data flattening, and presumably you're going to be doing this in another application, which means you have to keep a bunch of things synchronized. Schemas are, to me, like the really hard one. And Mongo is a perfect candidate for handling a reporting application. Largely because of MapReduce support. This is how you're going to generate your reports. You're going to aggregate over a large collection of data. And also because it's schemaless. You can flatten it any way you want, and Mongo will be cool with it. So this is roughly how we're architecting our reporting app. You might be asking yourself, why are you going over a WAN? Well, in healthcare world, you cannot put sensitive things in the cloud. So we have a very uber safe, beefy stack at Rackspace. And so, but those things are expensive and painful to like queue up. And a little tidbit, you do not want to host your production Mongo server with your database server if you're going to be doing anything at all with it, because it will eat memory. But we also don't want to put this thing with Rackspace because, again, it's like, one, we don't really want to like have them trying to like mess with it, and it's expensive and contracts involved. And so as long as we can keep patient data out of this thing, we can put it on EC2, and that's a big win. So, but we do have to go over a WAN, and that kind of sucks. So we're implementing some sort of, we're sort of spiking on this in a number of ways right now. But there's going to be some REST interface in between these things where a client comes along and says, hey, I need this report, and it goes over and talks to the reporting application, and it does a bunch of MapReduce magic. But there's this transformation step that needs to happen to take the data from its native state in MySQL and put it into the flattened state that Mongo can do something with it in MapReduce. So there's going to need to be some large data going over the wire situation here, so it can get to Mongo and flatten it and throw it in there. So I think I put this slide in here originally because I wanted to see if anyone else was trying to solve this problem. If you are, I'd love to talk about it, share ideas and whatnot. And once we implement this, we'll definitely be doing some blogging about it. Our website is OptimisDev.com, and my blog is alexjsharp.com. But it should be pretty cool when it works. So I think I'm finishing up a little bit early. 10 minutes. Usually this talk generates a lot of questions. But if you want to get started with Mongo, again, I recommend using the Ruby driver first and just toying around. That's a really great thing about it, is that the barrier to entry is really, really low. It's super easy to install, especially if you're on a Mac and you're using Homebrew. Just brew install Mongo. And in production, it's all written in C++, so there's no other dependencies. It's just like the binary. They have binaries for everything. I talked about Mongo Mapper a little bit. Mongoid was developed in-house at HashRocket by a guy named Duran Jordan. It is, I've used it on one project. It's pretty awesome. They do a lot of work on it, and it works great with Rails 3. The syntax is fairly similar to Mongo Mapper. I would say the main difference is they sort of prefer using embedded documents whenever you can in Mongoid. You're allowed to do, like they provide facilities for doing references, but they definitely prefer embedded because that's one of the big benefits of using Mongo. Works with Rails 2 and Rails 3, and I don't want to single out Mongo Mapper. It may be using Active Model now too. I don't know. I haven't really done anything with it in a while, but I know Mongoid's using it. And then, of course, MongoDB.org. Lots of great documentation there. But most importantly, we must get to the whiskey bar earlier. Oh, tonight. That's supposed to be tonight, not tomorrow. Because it closed at midnight, and we only got to have one drink. So let's have some more whiskey tonight. And that's it. Anyone have any questions? I think there's a question over here to the right.
佐々木と申します。日本語でいいですよね。トランザクションはいらないよという話だったんですけど、一番単純な例として、銀行口座のアプリケーションを作りたいってことになって、A さんから B さんにお金を移すアプリケーションが必要になるとしたら、どうする可能性があるのか、あるいは諦めるしかないのか。
どのようなアプリケーション？
要は銀行口座のアプリケーション、 A さんが5000円持ってて B さん5000円持ってる、1000円移しますっていうアプリケーションを作りたい場合、絶対トランザクションが必要な例だと思うんですよ。そういうものを作りたくなってしまったら MongoDB でやるとしたらできる可能性があるのか、それともできないから諦める、MySQL 使えっていう話なのか。
銀行っていうこと。So the question was, how about you said that you can't have transactions over multiple documents in MongoDB. So what happens if you want to implement a banking application where, say, you want to transfer $1,000 from account A to account B? Is that possible with MongoDB, or do you have to just give up and try something else?
Yeah, you wouldn't want to do a banking application. Like any sort of financial important, like trading, banking, they actually say on the website, like use something else. So yeah, don't do a banking application in Mongo.
別物を使いましょう。
ありがとうございます。Thank you.
Thank you. There's one up here in the middle.
.日本語でお願いします。はい、すみません、日本語でお願いします。簿記の例が出てたんですけど、簿記だと、いろいろなその数字の合計を出したりとか、そういう数字系の演算をいっぱいしなきゃいけないことが多いかと思うんですけど、MongoDB はそういうのにも向いていますか？
So you had an example of accounting ledger application, right? So with most accounting things, you actually need to do a lot of calculations with line items and entries within the line items. So what kind of facilities or how does MongoDB enable that kind of thing?
Like the analysis itself?
Yeah.
So there's MapReduce, which I show or which I showed if you need to like aggregate and really do like aggregate statistics. But there's a lot of Mongo has a group function. It has a distinct function, and you can query over these documents just like you would in MySQL and do calculations in that way. I guess it would kind of depend. I mean, MySQL has a lot of functions built in, like sum, min, max, average, standard deviation, that kind of stuff. So the short answer is probably query what you need and do the analysis on the client side or at the application level.
Thank you.
訳さなくて大丈夫ですか？
大体わかりましたけど、お願いできれば。はい。
念のため、
はい、
例えば統計と集計の場合はMapReduceを使えば大体できそうなんですけど、他の計算だと例えばMongoだとグループとかはあるんですけど、多分 MySQL ほどそういうなんていうか関数は充実してないんで、例えば average とか sum とか多分ないんで、できるだけそういう部分は多分アプリ側でやるんじゃないかなっていう話です。
はい、ありがとうございました。
I think there's a question over here. Leonard, you're the man, by the way. Amazing. I guess keep your hand up if you have a question.
Oh, and can you pause after? Can you just weather mode so I can translate the question as well?
Oh, yeah.
To Japanese so that they can understand.
Oh, yeah, gotcha.
Great.
So 2 questions, if I may. One is like really short and simple, I think. Conventionally, where do you define and execute your indexes? Like if you don't have migrations, right? So.
2つの質問があって、1つ目は簡単で、マイグレーションがないからどこにクリエイティインデックスを書くのっていう質問です。
You could do some sort of deploy hook, like a script that runs on every deploy, because it uses this ensure index facility. It's not harmful to call them all again, and obviously that's nice because you don't have to maintain a schema.rb type of thing.
例えばデプロイするときにデプロイするたびにフックで、毎回インデックスを 貼ってみる。でMongoだと何度も貼ってみても問題ないので、そういうのは便利じゃないかなと。
And the other one, I know you didn't really get into replication, but on the like auto sharding subject, what sort of redundancy is there? Like, if you have multiple nodes, will Mongo auto rebalance if you lose a node that's in a sharding configuration?
まあレプリケーションの話はしないと言ったんですけど、オートシャーディングとかでいう話があったので、気になるポイントとしては、例えば一つのノードが落ちたらどうするとか、どのようになんていうか、リダンダンシーを実装しているのかなっていう質問です。
So there's really like two main replication strategies. There's traditional master-slave, and then there's replica sets, which is kind of similar to, it's new and it's similar to multi-master. With sharding, yes, if a node goes down, the rest of your nodes will communicate. There's another server in front, and we'll promote a new master. There's a quorum that happens, and they'll promote a new master.
2つのレプリケーションのモデルがあって、普通のマスタースレーブと、でもう一つはレプリケーションセットで、それが、マルチマスターと、ほぼ同じようなもので、オートシャーディングの場合は、例えば一つ落ちたらシャードに入っているノードがコールムを開催して、そこで新しいマスターを作っていくっていう話です。
Are there any gotchas to running Mongo in production on a single server configuration? I've heard sometimes that these document databases are actually designed to work best when they've got multiple servers.
例えば一つのサーバーでアプリも MongoDB を載せる場合に、なんか罠とかないですか？噂ではなんかそういうドキュメント系 DB は一つの独立したサーバーにデプロイするのに向いてるという話です。
Yeah, so there's been a lot of discussion about this, mostly incited from a blog post from someone on the Couch Core team. But the short answer is you should always be replicating or backing up in some form in production. You know, the most common case is going to be single disk failure. So regardless of what you're using, like you're screwed if you're not replicating or backing up somewhere. But the Mongo people are definitely very adamant. Like, yes, in production, you need to be replicating on to a different node somewhere.
Thank you.
一つの問題は一つでしかやらない場合は、バックアップは絶対取りましょう。でもともとモンゴは、なんていう複数のノードをある意味前提としているからアプリケーションを進めてるみたいですね。Does that actually, did you mean having the MongoDB database on the same server as your app server? Or just having a single master, no slave?
I did mean single master, but if there were any problems relating to having the app and Mongo in the same place, then that would also be good to know.
Yeah, so although on that point, in production, I definitely recommend not having it on the same server as your app server because Mongo will eat available RAM under any sort of load.
モンゴとアプリを同じサーブにするのはあまりお勧めしない。なぜなら、モンゴはできるだけ RAM を食ってしまうので。
Any other question? Oh, here we go. Sweet. There's two. Awesome. Maybe three.
ありがとうございました。さっきの例だと分からなかったんですが、MySQL のオートインクリメントみたいな感じで ID の自動裁判みたいなことはやってくれる機能はついているんでしょうか。さっきの例だとちょっと ID を手動で入れているように見えたので質問しました。
He would like to know whether there is an auto increment for IDs. So he knows that in the examples you just had the ID there, but is it
Oh,
auto-incremented or?
It's not auto-incremented, but Mongo will assign something. It'll assign a unique ID to new documents. By default, you can use. It'll do like something similar to like a unique SHA hash, but you can define your own incrementer if you want to.
オートインクリメントはないんだけど、デフォで、ユニークな、ハッシュみたいな ID を最初からつけます。で、自分のインクリメントも定義できます。
ありがとうございます。
じゃあそろそろ時間なので、それで最後にお願いします。はいはい。
ありがとうございました。ですね、例えばマスターデータと呼ばれるようなもの、部署名であるとかそういったものをエンベディッドドキュメントとして持たせたときに、それぞれ独立したデータになってしまうので、例えば部署名の一括変更をするみたいなときに、それが入ったデータを全部アップデートしないといけないんだけど、 MongoDB は複数ドキュメントを一貫してアップデートすることができないというような問題があると思うんですけれども、そういうもんなんでしょうか。
Okay, so he's curious about instances where you have a set of master data. For example, the names of departments in the organization, and you've got those as elements in a document, in multiple documents. So in an RDBMS, you would just update the entries in the master table, which are referenced from the entries in other tables. So in MongoDB, would you just have to update every single document manually with embedded documents?
I'm not sure I understand the modeling here, so can you explain it again?
So for example, you've got the names of the states, 52 states, right? And
you're saying
Texas gets merged with New Mexico to become New Texaco.
That'll never happen. Not if Texas has anything to do with it. Yeah. In that case, you probably wouldn't store the states as embedded documents, or you could. You probably wouldn't want to if it's something that is truly, if something is truly relational, you should have a relationship to it. You shouldn't try to force things into embedded documents that aren't by nature embedded in the real world. But if they were embedded, yes, you would have to iterate through all the documents and update the embedded documents individually, because that's the only way you can get at embedded documents, through their parents.
リレーションのデータの場合は、リレーションを使いましょうっていう話です。
Thank you.
Last question.
並列処理についてちょっとお伺いしたいんですけど、ロックの単位っていうのはレコードごとなんですか？それとあと、インデックスの作成とかしてるときに、レコードに対してアクセスできるのかっていうことについて教えてください。
So it's a question about locking. So in MongoDB, is it a record level lock? And if you're updating the index, can you access records?
So there are two ways to do it. They recently added background indexing. It'll build the index in the background, and it won't block. I believe by default, updating an index blocks that collection.
デフォだと、インデックスを作っているときに、レコードのアクセスをブロックする。なんだけど、最近追加された機能が、バックグラウンドインデックスなので、非同期的にバックグラウンドを作成すると。
同時アクセスっていうか、ロックについてはどうでしょう？
How about locking of records?
Mongo does not have any concept of record locking natively.
So if two processes are trying to access and change the same data at the same time?
Okay, so there's this comes up right in distributed environments with multiple nodes. There's a command called get last error that will tell you if the record is in the state that you believe it to be, and if it's not, then it'll. For example, if you try to update a record that was in one state when you tried to make the update, but in between someone else updated it, get last error will tell you like you can't do that.
Do you have to call that explicitly?
Yes, you do.
get last error っていう、ロッキングは基本的にないみたいで、get last error っていうコマンドがあって、それがアップデートしようとするときに、アップデートする時点で期待していた内容と違うかどうかっていうことをチェックしてくれるものはあります。で、複数のがあるときに結構必要になるみたいです。
So the short answer is there is no locking.
短く言うとロッキングがないです。
ありがとうございました。
Thank you. I think that's it.
ありがとう。